Hi, this is Ed Kohler with Extreme Networks, and I have a very interesting challenge for you. Extreme Networks' secure campus fabric based on shortest path bridging provides for some very formidable testing boundaries for security. This is all about a penetration testbed and hackathon that you're invited to participate in or view a demonstration if you don't feel you have the skills. Now, we are used in some of the most secure networks on the face of the globe. And you don't get there by simply doing a sales presentation. You have to go through some rather rigorous testing. Now, the Secure Campus Fabric is based on a unique carrier-grade legacy, and we'll talk about some of the details as we move forward. But this technology has been submitted to various agencies and organizations for various intensive testing and analysis. What we've done here is we've engineered a downsized implementation that will kind of give you a taste of what it's about and the key technical aspects of the technologies and what's involved in order to make this type of security a reality. It's important to understand these technical traits, even if you're not going to participate, because you really need to understand what is under the hood to make it so difficult not only to penetrate, but even simply to enumerate, which means to document the actual network topology and perhaps even characteristics of the systems within it. Now, talking about the technical aspects, first of all, Fabric Connect is built on a data plane based on IEEE 802.1AH, and that is the legacy carrier transport that we talked about in the previous slide. It introduces the concept of a MAC addressing hierarchy. And with that hierarchy, we are able to use it as a tunneling mechanism known as MAC and MAC, which provides for rather absolute separation of the user subscriber from different subscribers, but also, more importantly, from the network service plane itself. So all topological aspects of Fabric Connect are supported and maintained at the Ethernet forwarding plane. IP as a protocol plays no role in establishing routed path behaviors or the topology within the fabric. So it is black from a IP topology perspective because IP really plays no role. There is also no flooding or promiscuous forwarding within the fabric itself, within the service core. Instead, it uses something termed as tandem replication, which is used to handle broadcast unknown, i.e. MAC learning, and also multicast. As such, MAC learning, broadcast, and multicast really becomes divided and localized at the service edge, which is a great thing for two things. First of all, scale, and then secondly, for security. Now, we need a control plane in order to automate the actual behaviors of the 802.1AH data plane, and that is the role that ISIS is providing for the fabric. It basically programs the link state database resident within each Fabric Connect node. It is therefore an inherent distributed control plane. Okay, we don't have a centralized controller. ISIS does not forward any user data, so it does not act in the traditional routing sense. It's strictly a programming substrate for the link state databases. All forwarding behaviors happen through circuit-based entities known as individual service identifiers, and those actually provide for Ethernet switch path directional graphs to support the data forwarding plane behaviors. And you will be in one of these ISIDs, and you will be challenged to get out of the ISID you're in and enter traverse to other service entities. So these service entities can be various. They can be layer 2, they can be layer 3. You will be locked into a layer 2 if you're participating in the hackathon, and the targets will be layer 3 service boundaries, IP VPNs. So this kind of gives a quick summary for what you're going to be dealing with. Starting at the upper left side, we have the three different planes. First of all, the 802.1 data plane, which is how forwarding happens. And then we have the control plane provided by ISIS. And notice that we have LSDB synchronization. It happens through the use of the ISIS protocol. And then on top, we have the Fabric Connect service plane, which provides us for the differentiations, i.e. the type-like value extensions shown at the bottom of the cloud, where we have the different service categories, layer 2, layer 3, VPN, multicast, IPv6, so forth, so on. Now, all of this, as we move over to the right-hand side, is synchronized, and this creates an environment where the fabric has a synchronized programmable link state database that's resident within each node. And inherent in that is the service separation, which means we have the localized MAC learning, DSN separation, and then plus we have the division between local versus remote table separation, which makes it very, very difficult to do any type of spoofing or poisoning of ARP within the environment. And then coming around full circle, we have the actual Ethernet switch path-based service separation, which are the whole inherent characteristics of the individual service identifiers. So here's the scenario. You are a contractor and you're working for a company. You're also a bit of a hacker on the side. You've been shoulder surfing, dumpster diving, maybe walked in and snapped a whiteboard or done some social engineering. In any event, in the process, you've gained some IP address information, and you might even have some passwords, and you want to validate that information so you can mount a later attack. You are given contractor access for your job requirements via a dedicated layer 2 virtual service network. And you will have complete and unfettered access to the internet to do your job, which means you can run a VPN client, you can do whatever you need to do, plus you can download whatever tools you feel you need to have in order to mount your attack. Just one note, attacking the portal or gateway that gets you out to the internet does not constitute a successful attack. The only thing you do is you shut down yourself and you shut down the other participants, so not only is that not a successful attack, but it's just not cool. So success is only determined by penetration of the targets that are listed at the show booth. So here's a quick look at a physical high-level topology. You're coming in as the penetration access, and you will get DHCP services via a default gateway that will allow you access out to the internet and give you complete access to whatever you need to get or access. The targets are listed above. We have 2 cameras. We have a receiver for the environment, and note that this is a 10.50 network. And then we have a secondary network, a 10.60 network, which will involve multicast IPTV distribution. Your challenge is to access these targets as listed on the slide. In no other instance is any other target a valid object of attack. So the rules of the road are fairly simple. All participants are required to sign a memorandum of understanding documenting proper participation in the event. In order to claim the prize, and this is actually documented in the MOU, is that the successful participant must disclose all methods and tools, as well as demonstrate a successful penetration in a dedicated session with Extreme Networks staff. Participants are not to disclose the tools and methods used to the general public. They are to keep that private between Extreme and themselves. Only the listed targets are valid attack points, as I've said before. Any other endpoints not listed are not part of the penetration test and will not qualify. Therefore, the rest of the show, the hotel, if you do not comply with this, there could be possible legal ramifications. So just a word to the warning, stick to the targets only. Beyond that, good luck.